and it can accelerate a 2-ton car to 60 miles an hour in 2 seconds. The RPM is so crazy that just the centrifugal force wants to expand the rotor.
American just flipped the script on electric motors. For years, EVs have pushed limits, but nothing prepared the world for this. At the heart of Tesla's latest Model S Plaid is a motor so compact you could pick it up with one hand, yet it unleashes more power than most supercars. The rotor is wrapped tightly in carbon fiber, an engineering choice that sounds simple but changes everything. In traditional electric motors, metal components swell under heat, wear down under pressure, and eventually fail. Tesla's carbon fiber sleeve locks the rotor in place, keeps a perfect micro-thin air gap between rotor and stator, and stabilizes the motor even at insane speeds. The result? Over 20,000 revolutions per minute, well beyond the 16,000 RPM where most high-performance motors start failing. That leap isn't just numbers on paper. It translates into more torque, higher efficiency, cooler operation, and a motor that endures stress without wasting energy. Every Tesla fan who has seen this in person talks about how it feels almost unreal, lightweight, powerful, and smooth all at once. Motor Trend verified these speeds during testing, and even they admitted this was something they had never seen before. But Tesla didn't stop at just performance. Each motor is small enough for a single engineer to lift during assembly, proving that you don't need massive machinery to achieve record-breaking power. And with this breakthrough, the days of traditional limits where heat, weight, and materials cap performance are over. What Tesla created here isn't an upgrade, it's a complete reimagination of what an electric motor can be. And this is just the beginning, because when you combine extreme RPMs, carbon fiber innovation, and flawless engineering, you unlock a level of driving performance that feels almost science fiction. But that wasn't the whole story. What happens when you put multiple of these motors together, and what that means for speed, torque, and endurance? That's coming next. The real proof of Tesla's new motor isn't just in engineering marvels, it's on the road. The Model S Plaid, powered by 3 of these motors, blasts from 0 to 60 in under 2 seconds. That's faster than almost any car in history, including some of the world's most legendary supercars. Independent testing clocked it at 1.98 seconds, with a quarter-mile time of just 9.25 seconds. Top speed, once software limits are lifted, a staggering 200 miles per hour. But speed alone doesn't tell the full story. Older performance EVs often burn through batteries like rocket fuel, trading range for raw power. Tesla's Plaid doesn't. Its design channels energy directly into motion with almost no loss. No oversized radiators, no complex cooling systems, just clean, stable output. Efficiency that seems impossible when paired with over 1,000 horsepower. EPA data confirms it. On 21-inch wheels, the Plaid hits 348 miles of range and 101 mpge. Real-world highway tests show it still manages 300 miles at 70 miles per hour. That's proof this motor solves the biggest headache for performance EVs, the trade-off between speed and range. The result is brutal acceleration, enduring efficiency, and a motor that feels alive under your hands. You can push it hard without worrying about overheating or wasting energy. Tesla didn't just make a fast car, they created a machine that's smart, efficient, and relentless. And with such a lightweight, compact design, the motors are easier to manufacture and maintain than traditional high-performance units. But speed and efficiency aren't enough to leave competitors behind. Tesla's next move? Production innovation that takes these breakthroughs and turns them into mass market dominance. That's where the story gets even more fascinating. Tesla didn't just revolutionize the motor, they reinvented how it's built. Each carbon-wrapped rotor allows a motor that's incredibly powerful, yet small enough for a single engineer to lift. That compactness doesn't just make assembly easier, it transforms production efficiency and scalability. Imagine building over 1 million high-performance motors without relying on heavy machinery or complex processes. The next generation of these motors takes it even further. Tesla managed to eliminate all rare earth elements performance, cut silicon carbide usage by 75%, and bring the cost of a single unit down to around $1,000. That's an industry-shaking figure, unheard of for motors that outperform nearly every competitor. 3 of these motors in a Model S Plaid produce a combined 1,020 horsepower and over 1,050 pound-feet of torque, yet each motor is light, compact, and astonishingly easy to handle during assembly. Production innovation doesn't stop at materials. Tesla's approach simplifies the design, reduces complexity, and makes mass manufacturing far more cost-effective. Every part of the process, from winding the rotor to assembling the drive unit, is engineered to scale at speed without sacrificing performance. This isn't just efficiency, it's domination by design. And while competitors are still struggling with legacy production lines, Tesla is already thinking about what comes next: faster assembly, lower costs, and a system that can adapt quickly as new technology emerges. But building better motors isn't the only way Tesla is leaving rivals behind. What comes next is the bigger picture: how the company's entire approach to EVs crushes the competition. While Tesla was perfecting its motor and production, the competition was scrambling to catch up. Legacy automakers like Ford, General Motors, Toyota, and Volkswagen poured billions into EV development, but most of their cars were still built on platforms designed for gasoline engines. That meant heavier vehicles, lower efficiency, and higher production costs. Startups like Lucid and Rivian promised innovation but struggled with scaling, losing billions or barely hitting production targets. Even BYD, dominating EV sales in China, relies heavily on low-cost hybrids and compact models, and its global expansion faces tariffs and trade restrictions. Tesla's edge isn't just in motors or batteries, it's software. Its full self-driving system has trained on over 3.6 billion real-world miles as of early 2025. Compare that to competitor systems like GM's Super Cruise, which logged around 300 million miles. That kind of data advantage means Tesla's cars learn faster, adapt smarter, and improve constantly. And because Tesla designs its own 4680 battery cells, the integration between motor, battery, and software is seamless, something most competitors can't match because they rely on outside suppliers. The result is staggering. While others are still catching up to yesterday's breakthroughs, Tesla has already moved on to what's next. Ford's Mach-E weighs hundreds of pounds more than Tesla's Model Y, and the company lost over $1.3 billion in EV operations last quarter. Lucid can't scale beyond niche luxury sedans, Rivian is losing tens of thousands per vehicle, and legacy automakers are struggling with slow battery rollouts and assembly inefficiencies. Tesla, meanwhile, continues to innovate at speed, integrate its software and hardware, and maintain production margins competitors can only dream of. But it's not just tech or software. Tesla's domination comes from a global vision. The next step in this story isn't about catching up, it's about building an empire that no one else can match. That's where Tesla's global expansion comes into play. Tesla isn't just building better cars, it's building factories that redefine how electric vehicles are made. Take Gigafactory Shanghai. From empty lot to fully operational plant in under a year, it now produces over 750,000 Model 3 and Model Y vehicles annually. And unlike most foreign automakers in China, Tesla owns it outright. No joint ventures, no local partners, just full control and full profits. Then came Gigafactory Berlin. Within a few years, it ramped up to 500,000 Model Y units per year, producing nearly 5,000 vehicles every week, faster than Volkswagen's own nearby EV factory. Back in the US, the Austin Gigafactory is already past 400,000 vehicles, and with Fremont combined, Tesla's US production capacity nears 1 million cars annually. Using massive casting machines called gigapresses, entire sections of the car frame are formed in under 2 minutes, speeding up assembly while reducing costs. And Elon Musk isn't stopping there. Tesla has secured land in northern Mexico for a new Gigafactory, planning a $10 billion investment that could create over 20,000 jobs and start production as early as 2026. In South America, the first Tesla location opened in Santiago, Chile, combining showroom, service center, and supercharger hub. Saudi Arabia saw a flagship store launch in Riyadh in April 2025, with more locations coming to align with the country's EV vision. India is next, with plans to sell imported vehicles while preparing a local factory to enter the market before domestic brands rise. What makes all these factories remarkable isn't just scale, it's automation. Giant robots, high-speed lines, and die-casting machines work together to slash production time, reduce errors, and lower costs. Tesla even patented a system to build entire car sections simultaneously, snapping them together like Lego blocks. Faster, cheaper, smarter. It's a global empire designed to outpace the competition at every turn. And having factories around the world is one thing, but what truly powers Tesla's dominance is the infrastructure that ties them all together. Next, we'll see how its charging network transformed EV adoption worldwide. Tesla didn't just build cars faster and smarter, they made charging effortless. While other EV owners stress over adapters, dead ends, and slow networks, Tesla drivers just plug in and go. That's the result of over a decade of planning. Back in 2012, when EVs were still treated like experiments, Tesla started building its Supercharger network. Fast forward to early 2025, and there are over 7,100 stations worldwide, with more than 67,300 stalls, far more than any other fast-charging network. Reliability is nearly flawless. Tesla reports 99.97% uptime, meaning you pull in, plug in, and get back on the road with no hassle. The network keeps evolving. V3 superchargers already deliver 250 kilowatts, enough to add 200 miles of range in just 15 minutes. The next generation, V4, pushes 325 kilowatts with built-in adapters so non-Teslas can charge too, even accepting credit cards without an app. Tesla opened its once exclusive network to rivals like Ford, Rivian, and GM, creating a revenue stream while strengthening its dominance. Globally, dual cable chargers in Europe already serve multiple brands side by side, and in China, Tesla logged over 60 million supercharging sessions in 2024, double the previous year. Mega sites with over 100 stalls, solar canopies, and energy storage ensure the system is not just fast, but resilient. Tesla's approach is integrated, from circuit boards to software, allowing updates to roll out overnight globally without physical intervention. Drivers rarely notice the complexity, they just experience seamless, worry-free charging. And this isn't just convenience. By establishing the North American Charging Standard, NACS, and convincing automakers to adopt it, Tesla set a new industry-wide standard. Its chargers became the default infrastructure, saving competitors billions and further locking in Tesla's advantage. But the real secret isn't visible to drivers. It's the AI powering every mile, learning from every journey. That's where Tesla's hidden beast, Dojo, enters the story. Tesla's advantage isn't just metal, motors, or miles. It's intelligence. Behind the scenes, a supercomputer called Dojo is quietly shaping every Tesla on the road. While most automakers rely on simulations or rented cloud servers, Tesla built its own custom system from the ground up, designed to handle the staggering volume of real-world driving data captured by its fleet. At the heart of Dojo is the D1 chip, a marvel packed with roughly 50 billion transistors and 354 cores. But Tesla didn't stop at one chip. 25 chips are soldered together into a single training tile, moving 36 terabytes of data every second and performing 9 petaflops of computation. 6 tiles form a tray, 2 trays a cabinet, and 10 cabinets a full exapod, a computing powerhouse with over 1 million cores, crossing the exaflop barrier, over 1 million billion calculations per second. Why does this matter? Because Tesla isn't training AI with cartoons or simulations. They use real driving footage. When a car encounters something unusual, a dog on a skateboard, a flipped truck, a rare traffic scenario, that moment is captured and sent back to Dojo. Within hours, it's training the next iteration of Tesla's self-driving software. Engineers report about 1 million miles of new driving footage every hour feeding the system. The speed and scale are unmatched. Dojo allows Tesla to roll out smarter full self-driving updates every few weeks instead of quarterly. The cost savings are enormous, too. Building its own chips avoids expensive reliance on NVIDIA GPUs, which have seen massive price spikes and shortages. This independence doesn't just reduce costs, it gives Tesla control over the entire stack, from hardware to data to software, creating a system no competitor can replicate. And the potential doesn't stop at cars. The same infrastructure could train humanoid robots, optimize energy usage across Tesla's solar and battery networks, and power entirely new AI services in the future. For drivers, it's invisible, but its effect is unmistakable. Smoother handling, faster reactions, and constant improvements delivered over the air. Tesla's AI advantage isn't flashy, it's quietly unstoppable. Next, we'll explore how all these pieces, motors, factories, software, and AI, combine to give Tesla a grip on the global EV market that no one else can match. All the pieces come together to form something larger than just cars, Tesla's global empire. Motors that outperform, factories that scale, software that learns faster than any human or competitor, and AI that constantly improves every mile. It's a system built for speed, efficiency, and control everywhere. Tesla doesn't just respond to the market, it shapes it. While other automakers struggle with supply chains, outdated factories, and slow software updates, Tesla expands aggressively. In China, its wholly owned Gigafactory Shanghai dominates local production. In Germany, Berlin produces more vehicles faster than traditional automakers. In the US, Austin and Fremont together approach 1 million units annually, with Texas's gigapresses reducing assembly times dramatically. Plans are already underway for Mexico, South America, India, and more. Each new factory isn't just production, it's automation, scale, and efficiency rolled into one, giving Tesla an edge that rivals can't match. The Supercharger network reinforces that dominance. Tens of thousands of fast, reliable charging points worldwide turn long-distance driving into a stress-free experience. By opening the network to competitors, Tesla not only creates revenue, but sets a standard the rest of the industry now follows. Every mile driven is smarter than the last, thanks to Dojo. Every update, every improvement, every innovation compounds. Tesla's future vision is clear: independence, control, and relentless innovation. It's not just an electric car company, it's an AI company, a manufacturing powerhouse, and a software leader. The company's vertical integration, from batteries to motors to AI, creates a moat no legacy automaker can cross quickly. And while startups flail to scale or raise billions, Tesla moves with unmatched precision and speed, shaping markets before competitors even enter them. The result? A company that doesn't just lead in EVs, it redefines what's possible in technology, energy, and mobility. The motor that seemed like just a performance upgrade is actually the heart of a system designed to dominate. Tesla isn't playing the EV game, they're rewriting the rules entirely. Tesla isn't just about cars anymore. The motors, factories, AI, and charging networks are only part of the story. What really sets Tesla apart is its ability to innovate in ways no other company dares to. It's a tech ecosystem that reaches far beyond personal vehicles, quietly influencing energy, robotics, and global infrastructure. Take Tesla Energy, for instance. While competitors focus narrowly on vehicles, Tesla is building a complete energy ecosystem. Solar roofs, power walls, and megapack batteries allow homes, businesses, and even entire cities to store and manage energy efficiently. Imagine a neighborhood powered almost entirely by the sun, with excess electricity stored in massive battery arrays, ready to stabilize the grid during peak demand. That's not a future vision, it's happening now. Tesla energy installations are growing exponentially worldwide, quietly positioning the company as a leader in decentralized energy. Then there's robotics. Tesla isn't just building AI for self-driving, it's building humanoid robots designed to handle tasks humans find dangerous or mundane. The Tesla bot, also known as Optimus, leverages the same Dojo AI training system that powers full self-driving. That means every breakthrough in perception, decision-making, and efficiency instantly feeds into robotics. A Tesla car that sees, learns, and reacts to real-world challenges is also teaching robots to operate safely in complex human environments. Over time, these robots could disrupt labor markets, logistics, manufacturing, and more. Yet most people don't even realize it's happening. Tesla's software ecosystem is another invisible force. The company doesn't just build hardware, it writes the operating system, manages over-the-air updates, and controls the AI that powers every vehicle and robot. That gives Tesla unparalleled control. Unlike competitors who rely on third-party software or fragmented supply chains, Tesla can innovate, fix issues, and implement improvements faster than anyone else. Your car, your home energy system, and even future Tesla robots all benefit from updates rolled out almost instantly, globally. Tesla's approach to vertical integration creates another secret weapon: data dominance. Every Tesla on the road collects millions of data points, traffic patterns, battery performance, weather effects, sensor readings, and sends them back to the central AI. Dojo analyzes this massive data stream, training systems that improve continuously. Every mile driven makes every Tesla smarter, every robot more capable, and every energy system more efficient. Competitors don't just fall behind, they're trapped trying to catch up to yesterday's technology, while Tesla already trains for tomorrow. And finally, Tesla is quietly monetizing these innovations in ways the public barely sees. Supercharging stations now serve competitors' vehicles, creating a new revenue stream. Energy storage and grid stabilization could turn Tesla into a utility powerhouse. AI systems trained on real-world data could eventually be offered as a service to other companies, generating billions in untapped revenue. The motors, the batteries, the factories, they're all part of a larger play, building a self-reinforcing ecosystem that's nearly impossible to replicate. In short, Tesla is no longer just an EV manufacturer. It's an AI company, an energy giant, a robotics pioneer, and a software innovator, all rolled into one. Every breakthrough in one area feeds into the others, creating a synergy that leaves competitors scrambling. This is why the motor that accelerates a 2-ton car in under 2 seconds isn't just a performance marvel. It's the beating heart of a global empire poised to redefine technology, energy, and mobility for decades to come.